to the concepts video on graphs of polynomial functions. So in the previous section, we studied quadratics, meaning of the form x squared, right? So quadratics are anything where you have some variable being squared, or to the power of 2, right? So now what we're going to do in this section is study more general polynomials, okay? So we're going to study more general polynomials, okay? And again, polynomials just means the sum, like you're adding different power functions, right? So something like x to the 5th plus x to the 3rd, and then like minus 1 or something like that, right? So what we're going to do is study more general polynomials like this using, and I'll abbreviate here, horizontal intercepts, okay? So I'm just going to use HI for horizontal intercepts to analyze the behavior of such polynomials. But we're not just going to use any old polynomial like this one here. This one looks pretty terrible and we wouldn't know what to do with it. But what we're going to use are polynomials that are ones we already know how to factor, ones we know how to factor pretty easily. We can like take something out like a common term or something like that, or we can FOIL it out, or like do the opposite of foiling, so factoring. So ones we know how to factor on our own, okay? Or ones that are already factored for us. Okay, so just to make it easier on ourselves. Factored for us. Alrighty, so now let's do an example of what we could see. Okay, so here's the first exercise. We have find the horizontal intercepts of this function here. Okay, so let's write down the function. So we have f of x is equal to, okay, x to the 6th. That looks a little bit scary. Then we have minus 3x to the 4th, still a little bit scary, plus 2x squared. Alright, so that's kind of intimidating, but we do see that there's a common term in each of these, or a common factor in each of these terms, right? What we can do is pull out an x squared from each of these terms. So if we pull out an x squared in front, we get x to the 4th is left behind for this first term. A negative 3x squared is left behind for the middle term, and a plus 2 is left behind there, okay? So this looks a little bit simpler than what we started off with, but still, this guy in parentheses looks a little bit intimidating, right? But what we can do is actually try to factor this, just factor it out, right? So we're just going to write x squared and x squared, let's say, and we have to get to a positive 2, so that means we have to have 2 negatives in the middle there because they have to add up to some negative value. We could just write a 2 here maybe, and how about a 1 right there? And if you do FOIL it out again to get back to this, it does work out, okay? So then if we factor these even further, we get x squared times, so this one factors into x plus the square root of 2 times x minus the square root of 2, okay, because that's the difference of two squares right here. As is this one. This one's a little bit more simpler. It's a little bit more simple and more commonly seen, of course. Okay? So something like that. So we're going to have a lot of roots here, right? Or a lot of horizontal intercepts. Okay? So now to find our horizontal intercepts, that just means, okay, when is our function equal to 0? So we just stick a equal 0 on the end there, and we kind of just figure out what x could be. So horizontal intercepts are at x is equal to, well, x being 0 here would make this whole entire thing on the left side be 0, so x could equal 0. What else could it equal? It could equal a negative 2 from this one. Negative square root of 2. That is, from this one we get, well, x could be a positive square root of 2, which would make the left side be 0. From here we get, well, x could be positive 1, or it could also be a negative 1. Okay, so see here how we got 5 different roots or zeros or horizontal intercepts, okay? So just a tip, horizontal intercepts are often referred to as zeros, okay? Zeros or roots or solutions. But anyways, these are the common terms that mean all the same thing. Okay, so now here's an important example. We're going to study the behavior of this function given to us right here, okay? And see, this one is one of the examples where it's a polynomial that's already factored for us, right? Because it's not like one huge mess of polynomial, but it's kind of factored already, which is nice, okay? So, two important things to notice. or to note about graphing polynomials and studying their behaviors is that, okay, so the overall long-run behavior, which we've run into before, right? No pun intended. Long-run behavior depends on your leading term of the entire polynomial, okay? Leading term. So that's point number 1 that I want to make. And then point number 2 is that the short-run behavior, conversely, so short-run behavior depends on the power, meaning like the exponent, depends on the power of your root, of each root, we could say, of each root. And again, root is the same thing as 0, is the same thing as horizontal intercept. And I'll go into more detail about what each of these mean. Okay? So for number 1, we have, well, we can look at the long-term or the long-run behavior of our f of x, depending on the leading term. But the thing is here, the way that they give it to us, we don't see a leading term kind of explicitly, right? It's not there. It's kind of like, okay, there are x's floating around and other numbers and powers, but what should I do? So the thing here, the key is that, well, all we need to do is identify what will be the leading term, okay? So basically when you multiply everything out, when you FOIL out everything and double FOIL it and everything like that, what is the highest degree going to be on our x, on our variable, right? So if we look at this, here I'll write down what we were given, x minus 2 squared, x plus 1 to the third. So it basically just depends on all of the powers, right? So, for example, from this guy here, it doesn't really matter about this plus 3 because that's not going to add any degree, or that's not going to add any power to our leading term, right? So, for example, if we were to FOIL it out, this 3x wouldn't be anything because we already have an x here. So this x times another x would add to our power. So what we're going to ultimately do, I know this is a little bit confusing, but you're basically just going to jump over all of the numbers, all of like the constants, right? So like ignore this 3 here, ignore this negative 2, and ignore the positive 1, okay? And we're just going to take the powers, stick them on the x's, so we have like an x squared, and an x to the third, and this kind of multiplies up to just an x to the 6th, okay? And so this ultimately is going to be our leading term. If you were to take this whole expression for our polynomial and kind of just multiply everything out, distribute everything and the numbers as well, you would find that the leading term is going to be like a 1 in front. So positive 1 x to the 6th. Okay? So this is our leading term, and like I said in point number 1 here, this determines our long-run behavior of our polynomial. So if we look at it, it's like, okay, so this is an even power, right? 6 is even, and it's positive. Okay, so that means that on both sides, in the long run, our graph will be traveling up to infinity on both, as x goes to negative infinity and as x goes to positive infinity, aka in the long run. Our graph is going to look like that. Okay? Alrighty, now for point number 2. So let me start on the next slide to explore number 2.